Welcome back. I wanted to take a moment to do one more of the single replacement reactions with you to jog your memory a little bit on single replacement. So let's take a look at sodium is added to water. Okay, now this is a tricky this is a tricky one of the single replacement. So let's just go ahead and write it out. Sodium is a metal, so I've got Na, and that's a solid, plus water. Now, of course, we already know that water is H2O, but here's how I want you to write it. I want you to write it slightly different. I want you to write, instead of writing H2O, I want you to write this as HOH, okay? And here's how I want you to view this. I want you to view this as hydrogen, okay? And I want you to view this as hydroxide. So we can kind of call water hydrogen hydroxide at this point. Okay, and of course we know that water is a liquid. So now when I do my single replacement reaction, here's what's going to happen. Remember, sodium is going to switch spots with the one that's most like itself, either the metal or the one that forms the positive cation. Well, I know that hydrogen in acids and stuff forms a positive cation, so that's who sodium is going to switch places with. Okay, it's going to switch places with hydrogen. So now what we're going to get is we're going to get sodium hydroxide. Okay, if you write it out as H2O, a lot of times y'all try to put sodium oxide, which is incorrect. Okay, this is going to form sodium hydroxide. Plus, then I've got H to come over and be by itself, but can H ever really be by itself completely? No, it can't, okay, because it's diatomic, so it's going to be H2. So now when we are balancing this out, I've got one sodium, one hydrogen, two hydrogens, one hydroxide, one hydroxide. So if I put a 2 here, and then a 2 here, and then a 2 here, that should get it, okay? So that is going to be my balanced reaction. Now, hydrogen, when I look on the periodic table up there, it's red, so that tells me that that's going to be a gas. And sodium hydroxide, remember how I said that we're going to look at sodium or solubility rules in class, okay? Sodium hydroxide is going to be an aqueous solution, okay? Is it redox? Yes, it is, okay? It's not double replacement, so it's redox. Boom. Yes, okay? Or you can do the, oh, this is 0, and then it goes to +1, so it changes. You know, you can do that if you want. Or you can just say, oh, it's not double replacement. Okay? All right, that's enough single replacement. Let's go ahead and get into the great fun of double replacement. Okay, so when you have a double replacement reaction, remember, oh, good, here's our solubility rules right here. Okay, so these are the rules that we can use to determine if something is aqueous or if something is a solid. So check this out. I want you to see this. It says if a compound is soluble, it will get the AQ state designation, okay, because it's going to dissolve in water. Okay, if it's insoluble, so if we look on this little side over here and we see that, oh, it's insoluble, that means that it's going to form what's called a precipitate, okay, and it's going to get the solid state symbol designation. So that's what we can do. Okay, we're going to look at this list. So this tells us any compound that contains these polyatomic ions, these are always soluble. Anything that's ammonium, always soluble. Anything that's nitrate, always soluble, so on and so forth, okay? These are always going to be soluble. Now, some of them have exceptions, okay? For instance, chloride has an exception, okay? All chlorides are soluble except when it's paired up with silver, lead, or mercury. Easy enough, okay? All of these are always insoluble, okay? And so, yeah, that is what it is. So, now there should be one that says that all group 1s are always soluble. Where's that at? Oh, here we go. So this says compounds of ammonium and the alkali metal cations are exceptions for all of these. Anytime and every time that you have a group 1 metal as a cation, those are always going to be soluble. So let's take a little look-see-do here at some of these double replacement reactions. So I've got potassium cyanide, okay, which is KCN, okay, and that's reacted with 10,2 fluoride, SnF2. Okay, so my eagle eyes found a slight mistake. So to make this problem work out a little bit better, I changed this to potassium nitrite instead of potassium cyanide, okay? So we're going to do potassium nitrite is reacted with 10,2 fluoride instead. So according to my solubility rules, I come up here, I look for nitrite. Oh no, nitrite's not on there. Oh no, nitrite's not on there. Okay, and then I look down here. If a compound does not apply to any of the above rules, it is automatically insoluble unless it's reacted with an alkali metal or a cation. Ooh, well, I've got an alkali, so that tells me that this is aqueous. Okay, 10,2 fluoride. Let's see what I got up here. Okay, fluoride. Oh, there's nothing about fluorides up there. So that one must be, and it's not paired with a group 1, so this must be a solid. So what that tells me is that I'm going to take an aqueous solution and I'm going to dump it on top of a solid piece of 10,2 fluoride. Okay, so when I do this reaction now, I'm going to do the double switcheroo. Okay, that was the one that was like this, and then we switched it. Now we have a double switcheroo. Okay, so the ones that are the most similar, so my metals are going to be the ones who switch. So potassium's going to switch places with 10. Okay, so now I'm going to end up with 10. Now, here's a question for you. Does 10, is it still going to be 10 too? Absolutely. Okay, absolutely it is. It's still going to be 10 with a +2 charge. So now I'm going to have SnNO2, which nitrite has a -1 charge, and now 10 has a +2 charge, so this is going to be 2 of these, plus Kf. Okay, now let's go back to our solubility rules. Nitrite, remember nitrite wasn't up there, so that tells me that this is going to be a precipitate. Okay, it's going to be a solid. And potassium fluoride, potassium's a group 1, it's always soluble, making this one aqueous. Okay, so now the last thing that we need to do is we need to balance it, so let's go ahead and do that. I've got 1 potassium, we're good. I've got 110, we're good. I've got 1 nitrite, 2 nitrites. We're not good. Let's put a 2 here. Okay. So now I've got to go back and fix my potassiums. So if I put a 2 right there, that fixes my potassiums and it also fixes my fluorides. Okay. Is this one a redox reaction? Okay. Well, I've got +1 potassium, +1 potassium, -1 fluoride, -1 fluoride, +2 10, +2 10. So I did not have any change in oxidation numbers. What does that mean? That means that this is not a redox reaction. Or remember from earlier, I told you that if it's a double replacement reaction, it's not going to be a redox. Okay, so we will do plenty more of these. Actually, you know what? Let's do another one right now, and then I'll just make one last video for combustion. Okay, this has a common type of double replacement reaction. It's called an acid-base neutralization. Okay, when you have a neutralization reaction or a double replacement with an acid and a base, what's going to happen is you're going to have an acid and a base react together, and then that is going to give you always water plus a soluble salt. Okay, now I say the word salt and you automatically think of the stuff that you put on your french fries. Okay, salt is a term for any ionic compound. Okay, so a soluble salt is an ionic compound that will dissolve. So hydrochloric acid, HCl, AQ, is mixed with a solution of calcium hydroxide, CaOH2. Okay, and calcium hydroxide is soluble, so this is AQ. Okay, you go back and look up at your chart if you don't believe me. So now this is going to do a switcheroo with the things that are going to be most similar. So H is a positive ion, calcium's a positive ion. Those are going to switcheroo places. And so now I'm going to end up with calcium chloride, which is CaCl2 based on the charges, plus HOH. We've seen HOH before. That is water. Okay? Water, of course, is just a regular old plain Jane liquid, and calcium chloride is soluble. So that means that when calcium chloride is mixed with water, it's going to dissolve, making this aqueous. So let's go ahead and balance this bad boy out in green. So now, let's see here. Calcium, I've got 1 and 1. Hydroxide, I've got 2 and 1. So let's do a 2 right here. Chloride, okay, I need a 2 right here. So, and then 2 hydrogens and 2 hydrogens. So we are good. Is it redox? No, it's not. And everyone's happy as a clam. Okay, so that is an acid-base neutralization. That is double replacement. That is a little bit more of single replacement. That is solubility rules. And we're going to do one more video with combustion reactions later on. And have a great day.